Hi friends, this is Dr. Sangeeta. Welcome to my YouTube channel Techies. We are going to discuss about memory management in embedded systems. Memory. Static memory allocation. Variables are allocated in fixed memory regions at compile time. Stack-based allocation. It grows or strings as a function called and return with local variables while pushing and popping. So the basic operation that is used in stack-based allocation is push operation and pop operation. If it is push operation, the data is stored that is moved into the stack, and if it is pop operation, the data is moved out of the stack. Heap-based allocation. With heap with allocated blocks and free space, it illustrates the potential for fragmentation because you don't know how much space to allocate it and how to deallocate it. So the problem that occurs here is that fragmentation will occur. So you cannot, and how malloc function used in C, the same concept is used here also. Memory pools. Pre-allocated pools of fixed size blocks requests are fulfilled by taking a block from the pool. So the pre-allocated fixed size or taken it and moved to the moved from the pool. No memory unit considerations. If it is direct access, direct memory is used. In case of physical memory is used, in that case, you need not consider memory unit considerations. ARM memory management unit. Let us consider for ARM. Translation process from virtual to physical address using page tables and the TLBs. So what we are just doing it is that we are memory management unit, whatever the virtual address that is created by the CPU, it maps with the physical address using page table. If you want to take the address from the page table, then you have to add offset to it. Offset will be added with a page table to obtain the address from the table. And this will be stored in TLB. TLB is similar to that of cache memory. So it works for memory protection domains also. ARM memory regions and attributes. Different memory regions and their associated attributes. That is, we have seen cacheable, non-cacheable, bufferable, non-bufferable, and access permissions. This we have seen earlier. Memory management in ARM-based OS, it interacts between user process, the kernel, and the memory managed by the OS. It also manages virtual memory and paging. It is the case in case of ARM-based OS. In case of Raspberry Pi, images of different Raspberry Pi models highlighting the system on chip and RAM. It is the basic architecture that is used in Raspberry Pi hardware is that it is system on chip, and it shows CPU, graphical processing unit, and shared memory. This is available in Raspberry Pi hardware. In case of memory management in Raspberry Pi OS, what it does is that it highlights aspects specific to Raspberry Pi's Linux distribution. Bare metal programming. It is direct memory access without an OS. Okay, everything is customizable. You have to design everything in case of bare metal programming. That is what we have seen earlier. RP2040 microcontroller, it's static RAM banks and there is no memory management unit in it. It is a very simple microcontroller.
Thank you, friends.